So this time, suppose that the group of 12 people consists of 5 men and 7 women. And this time we want to make a team that has men and women. And how many 5-person teams can be chosen that consists of 3 men and 2 women? So the scenario here is a little bit different. So you're going to have to select some men and some women. So let's say, first of all, is the order important or not? No. You can choose your men first or your women first. Or you can choose one man, one woman, and so on and so forth. Okay, so I'm gonna select the men first, then I'm gonna select the women. Okay, so I have to choose 3 men. So in this case, I'm gonna select 3 men, and then I'm gonna select the 2 women. Okay, so these are the 2 women in this case. Okay, now the order is not important, so I'm gonna write that down. Order not important. Order not important. So the order does not matter. And the other thing in this case is that repeats are not allowed. So once you choose a man, that's it. You can no longer choose the same person again. So repeats are not allowed. So repeats are not allowed. Okay, as soon as I do that, I will recognize that this is an example of a combination. Okay, so I'm choosing combos in this problem all over again. Okay, so I'm gonna put that on the back burner for a minute and just kind of stare at the situation for a little bit. So if I choose the 3 men, then select the 2 women, in how many different ways can that be done? Okay. Now remember, every 3 men you can select have a group of corresponding 2 women. Okay. And similarly, every group of 2 women you select has a possible list of 3 men. So what I'm going to do is pretty much calculate the number of groups that contain the 3 men. I'm going to calculate the number of groups that contain the 2 women. And then I'd have to multiply the answers, because for every team of men, there's all the possible teams of women, and so on and so forth, vice versa. Okay, so I'm choosing the 3 men out of 5 possible men, and so that's going to be 5 choose 3. And I have to select the 2 women out of the 7, so 7 choose 2. Okay, putting that in the calculator, I get 10 and 21. So there are possibly 10 teams of men, and there are 21 teams of women. But now, what's the total number of teams that can be made? So the total number of teams, is pretty much gonna be the 10 times the 21, which is 210 teams. Okay, again, why did I have to multiply here? Why did I not add? I multiplied because every possible, team of men can have 21 possible teams of women. And so again, the tree is growing, kind of like that, which means I have to multiply. Okay, so now the question is, how many 5-person teams contain at least 1 man? So again, keep in mind that the order is not important and the repeats are not allowed in this case, which means, again, we're counting combinations. And what we want to do is count how many teams have at least 1 man. So here's the situation. So here's the universe of all the teams that we want to count. So basically, in the first box, we're going to have a team of 5 people, 1, 2, 3, 4, 5. But in this case, we want at least 1 man. So the first person can be chosen as a man, but the rest of them can be chosen as women. Okay. Now, in the second scenario, I can have 2 men followed by a choice of 3 women, and so on and so forth like that. So the next choice is going to be 3 men with 2 women, and finally the next choice is going to be 4 men and 1 woman, and I'm going to run out of space real soon. So the last choice is going to be pretty much all men, 1, 2, 3, 4, 5. So that's one possible way to count the answer, or to figure out what the answer is. So in this particular case, we would choose 1 man out of the 5, and we would select the 4 women out of the 7. And then we would select the 2 men out of the 5, then select 3 women out of the 7, and so on and so forth like that until the end. So 5 choose 3, and then 7 choose 2. The next one is going to be 5 choose 4, with 7 choose 1. And then finally 5 choose 5, and 7 choose nobody. Okay. Then I would take the first number, add it to second number, add it to third number, fourth number, and fifth number. So that would be using the addition rule, and that's because the sets are disjoint. I can do that. Okay. So that's one possible way to do the setup. Another possible way to do the setup is to count how many total number of teams exist in the universe, then take the teams that have all women. That might be a little bit faster, because if a team has all women, all I have to do is figure out how many women can go on a team of 5, and then subtract that from the total number of teams possible in the universe. So this uses method 1 uses the additional rule, so addition rule, and I'll present method 2, which is the one I'm going to write down and use it where I do the subtract rule. Okay, so since the sets are disjoint, I can add with the addition rule. But like I said, this is not super convenient because I have to put all these numbers into my calculator and it will take forever. So let's do method 2 instead. Okay, so in method 2, I'm going to count how many teams have all women. So, my team has 5 people and they have to be all women. So that's going to be 7, choose 5. And that can be put in the calculator to give us 21 basically. And the teams that I want, that's the number that I'm looking for. And how many possible teams can there be in this universe? So what's the size of the whole rectangle? Okay, we already calculated that, I believe, in a previous case. So how many possible teams can there be in the universe? I think we did that over here on this problem. There are 792 possible teams of 5 people out of 12. Okay, so I'm in the same scenario here because even though I have 5 men and 7 women, it still is going to be a 5-person team, so 792. So the total that I need, the total is going to be 792 minus 21, which is 792 minus 21 is going to be 771 teams. That's the final answer. And I feel like that would be a little bit faster, a little bit easier to get the answer. But, if you have time, go ahead and try the other option. See that it works. If you did the first method, you'd find out that the first number is 175, the second one is 350, 210, 35, and 1. And adding them gives you the same result, 771. I feel like 771 is the right answer, but I feel like method 2 is the better option in this case. If you decide to use method 1, by the way, just keep in mind that these numbers down here should always add up to 5 because that's the size of the team. There's always going to be 5 in total. So whether it's 5 plus 0, 4 plus 1, 3 plus 2, or whatever. And the numbers on top of your choose have to always add up to 12 because that's how many people you had originally in the team when you began. So regardless of how you do it, that's just something to kind of keep track of. Okay, so now how many teams will contain at most 1 man? So to say at most 1 man, that means your team could have all women or just 1 man. So I feel like that's easy to count, so we're gonna do it that way. So in the case when I have 0 men, I need 5 women, and in the case where I have 1 man on the team, I need 4 women, okay? So let's figure that out. So first, I gotta pick 0 men out of the 5 that are available, and then I gotta pick 5 women out of the 7 women that are available, okay? And again, we multiply the 2 answers, because technically every possible team of women can have a possible number of, any number of possible teams of men. And again, just keep in mind that the bottom 2 numbers always add up to 5, and the top 2 numbers add up to 12, okay? In the second scenario, I gotta pick 1 man out of the 5 men, and I gotta select basically 4 women out of the 7 that are possibly available, okay? And again, we gotta multiply the numbers because every possible team of women can have every possible team of men. And again, keep in mind that the numbers on the bottom right here add up to 5, and the ones on top add up to 12. So let's go ahead and put all this stuff in the calculator and get the answer. So again, 21 and 175, and the total is going to be 196. And why does this work? It works because the 2 sets that I'm counting are disjoint. These 2 sets are disjoint. In other terms, a team with no men cannot be mistaken for a team with 1 man. Okay, so that's the reason why we can separately count each one of them, 21, 175, and then using the additional rule, we can add them up and get the answer.